In lesson 37, a surprising boost from geometry, we're going to discuss a concept of imaginary numbers and how they're going to play a role in this case. So we're going to start by just making a couple of definitions and not worry about the opening exercise right now. But we're going to bring in something called a complex number system. And that's something as written in the terms of A plus BI. And so we want to note a couple of things that this part A, this is considered the real part. And this BI part, this is considered the imaginary part. And so it's this idea together that creates what is called the complex number system. And so in the lesson summary, if we took a look at it, I'm just going to write it right here. In general sense, we get this idea that we have a definition that I squared is going to be equal to -1. And if we were to square root this, then I would equal the square root of -1. And so we're going to base everything in this section off of these two ideas. We're also going to talk in this section about how to design the complex number grid, why it's necessary to have that, and all these things are going to be needed in order to be successful in this week's key concept. So to go through the opening exercise real quick, it just tells us to solve each equation for x. So in this case, x would be the obvious choice, x equals 1. In this case, x would equal -1. And if we added 1 to both sides, you'd get x squared equals 1. You'd square root both sides, so then x would equal plus or minus the square root of 1. And then the square root of 1 is just 1, so we have plus or minus 1. It's this last case is the reason why we discuss this complex number system. So if I minus 1 on both sides, I get -1. And then when I square root both sides here, I have the square root of -1. And so what you're going to see and learn in this lesson is this square root of -1 is going to bring itself to right here, where we're going to say I is equal to the square root of -1. And that's going to, like I said, take us into the complex number system. Now, your section goes from the opening exercise straight to example 1, but there are some topics we need to discuss before, so you're going to want to use this video and maybe revisit it or take a couple of notes as you look at it. So we're going to bring up a picture that looks like this, and we're going to talk about how to create this complex number system. So what you see here is a number line, standard regular number line, starts with 0 in the middle. Get your positives on this side, your negatives on this side. So one of the questions we answer is pretty much what does multiplying a value by a negative do? And so let's say we had this -2 or this +2 right here, and we multiplied it by -1, then we all know we end up with -2. We end up on this side of the number line. And so what it's telling us is that when we multiply by a negative value, we are doing a 180-degree rotation on the number line. So the question that comes into play with this is there something we can multiply by that would give us a 90-degree rotation instead of a 180? And so remember, thinking about a 90-degree rotation would be, what if there was something that we could put right through here, and then that we could multiply to this too, and when we did that, we would literally rotate from here and stop right here at 90 degrees. This is what the complex number system is going to address. So this is the first step to understand the complex number system, is by noting that if we multiply any number by a negative value, then it's going to rotate it 180 degrees. If we wanted to rotate a number by 90 degrees, that's what this piece shows here. we have to imagine another line to make use of to make that 90-degree rotation. So again, we can see if we would rotate 90 degrees, what would we expect to see here? What would we expect to see here? And so on. What would this axis look like? Remember, this is the real number line here. And so the question is, what is going on with this? Because we still see, a couple of notes. This is 1, 2, here's -1, here's -2, and so on. So our next image is going to bring in this idea of what if we multiply by I. So again, remember, we already mentioned that I squared is equal to -1. And so we're going to use this idea in this piece. So if we were to take this 1 right here and multiply it by I, our imaginary number, this is going to take us to the imaginary axis. So we have the real number line, and here we have the imaginary number line. And so when we multiply by I, we get this one. Same reason if you look right here, if we take 2 and we multiply it by I, we're going to get 2I. Now, again, while this may seem like what's the purpose and idea, this allows us to take a 90-degree rotation. Because if you stop and think about this idea, we said up here that I squared is equal to -1. Now, what does it mean to be I squared? That means I times I. And so we're going to let that equal -1. So if we were to take this idea and multiply this I by another I, then that's equal to I squared. And remember, I squared is equal to -1. And so that's like taking this 1, multiplying it by I squared, -1, and that's going to give you a full 180 rotation right there. And so that gives us this concept of multiplying by I to create this intermittent 90-degree rotation in the piece. And again, this would be the 180 rotation. We talked about that on the previous slide. And then I squared, or I, an individual I should say, will give us a 90-degree rotation. Now, if you stop and think about it, a 90-degree rotation and another 90-degree rotation gives you 180 degrees, which is this -1 right here, 180-degree rotation. So every time you multiply by an I, you have another 90-degree rotation along the axis, and so we bounce between the real to the imaginary, back to the real, down to the imaginary, and then back to the real again. The last image I'll show is the complex number grid. So we'll just kind of label this as the complex number grid. And so remember, we talked about a complex number being A plus BI, such that the A part is considered the real part, and then the BI is considered the imaginary part. So here we have our real number system. Here's our purely imaginary numbers. And so let's say we use the example that they have already on the screen right here. -1 plus 2I. And so this is the real, this is the imaginary part. So if we're talking about real, we go over to -1 on the real axis. And then we go up to positive 2I for the imaginary axis. And then we plot our point. Same reason if I was to look at this one right here. -1 minus 2i. So again, here's our real part. So we would travel 1 unit to the left, and then we would go down 2 units. So, if we looked at, say, another example, if I just said purely 2i, that doesn't mean there isn't a real part there. It would be a 0 in the front. So if we graph that, that means we wouldn't go left or right. We would literally go straight up on the imaginary axis to 2i, and we would put a dot. Same thing occurs if we had only a real part. Let's say my real part was 3. Then that means I would take, and I would literally just go over 3 spaces to the right, 2 right here, and I would plot this dot. And so that's generally how the complex number grid works in this idea. You'll see some more of these in the problem set that you can practice on your own. At this point, it picks back up in the student manual, where it tells you to simplify some of these. So example 1 is adding with complex numbers, which is not really any different than adding and subtracting like terms and variables. The only thing we want to keep in mind of is that every time we come across an I squared, we're going to replace it with a -1. So if we look at this, we say 3 plus 7, we get 10, and then 4i plus -20i is -16i. There's no I squared, so this is considered complete. This is written in the part where there's a real part, and then there's an imaginary part. So that creates our complex piece. In example 2, this is just subtraction with complex numbers. Same idea. So 3 minus 7 is -4. And then 4i minus -20i is +24i. Again, we always check to see if we have an I squared anywhere, because if we do, we'll replace it with -1. We don't see that in this case. So again, we see I plus bi, and that's going to be our final answer in that design. In example 3, we're going to multiply with complex numbers. So this is where you want to pay particular attention, because the I squared is going to actually appear in this particular example. So if we did first times first, 1 times 1 is 1, and then 1 times -2i is -2i, and then 2i times 1 is +2i, and then 2i times -2i is -4i squared. So now we can simplify a little bit, because these two are going to cancel out. So now we have 1 minus 4i squared. And this is where this rule comes into place. This is -1, by the way, not +1. And so now I minus 4i, so now we have 1 minus 4. We replace the I squared with -1. And so now you get 1 minus 5, or 1 minus 4. Or plus 4, because negative times negative is positive, so +4. And then our final answer is a 5. It's all in completely real. In this one, there's no imaginary part left over. Last example, they want us to show that -1 plus 2i and -1 minus 2i are solutions to x squared plus 2x plus 5. So we're going to do this by solving for x. So clearly this is not factorable. There's nothing that can multiply to 5 that's going to add equal to. This is a 1, so we don't have to worry about that. So we're going to do this by completing the square. So we're going to write x squared plus 2x. We're going to put a placeholder here and close that in. We're going to move that 5 to the other side so it becomes a negative 5. And then we have a blank right here. And so if I'm completing the square, remember, in completing the square, we want to consider b divided by 2. We want to square that. So 2 divided by 2 is 1. We square it, we get a 1. We put a 1 on this side so that way the equation is fair. And so now we end up with x plus 1 squared equals negative 4. We're going to square root both sides. So we end up with x plus 1 equals plus or minus a square root of negative 4. We can move the 1 to the other side. So x equals negative 1 plus or minus a square root of negative 4. So we see we're very close, but we need to address this. So remember, the two things that we look for is that I squared is equal to negative 1 and I is equal to the square root of negative 1. So if we simplify this out, right, this is like saying this idea. We have plus or minus, and we can replace this to negative 1 times 4. And so this is this. So when you square root this, you're going to get negative 1 plus or minus the square root of 2i. This part here becomes this part here. And so that verifies that this one and this one are solutions to this in that set of problem pieces by getting those answers. So at this point, that only leaves the problem set for you to work on. I believe I have it listed in Echo for the ones you want to do. So take a look at that and figure out what it is that we want to do.
The pronoun is usually